Hello, my name's Gabe. For this problem, we're asked to find the rectangular equation for the vectored value function r of uv is u times I plus v times j plus v divided by 2 times k. And we're asked to do that by eliminating the parameters u and v. So let's begin by first looking at this vectored valued function. The first thing we can think about here is if we look at what x is going to be, what y is going to be, and what z is going to be, we're going to have that x as a function of u and v is just going to be equal to u. Now we have y of u and v is going to be equal to just v. And finally, z of u and v is going to be equal to v divided by 2. So what we want to find is we want to find some sort of relationship between these variables, in particular between x, y, and z. And that relationship is going to depend on u, v, and v over 2. So something that I noticed might be something along the lines of, well, x, which is u, plus y, which is just v, minus 2 times z, just leaves me with x, because y is v, and z is v over 2. So if you multiply by 2, here we have v minus v, which is 0. So we're just left with x. And here we can subtract x from both sides of the equation, which leaves us with the relationship y minus 2z equals 0. So this right here is a rectangular equation for this vectored valued function. So looking at this equation, we'll see that this is a plane. All right. So now we want to go ahead and we want to graph our plane y minus 2z equals 0. And let's do this by first plotting a couple points. So the first thing I'll want to notice is our plane actually passes through the origin. So when x is 0, y is 0, and z is 0, we satisfy y minus 2z equals 0. And for any x value that we choose, as long as y and z are 0, this equation is satisfied. So we could think about having x equaling 2 and x equaling negative 2. So there's 2 more points. But really, any point on the x-axis is going to satisfy this equation. So let's think a little bit more. Let's imagine coming over 2 on the y-axis. So if we come over 2 on the y-axis, our z value is going to have to be 1, so that we satisfy 2 minus 2 is equal to 0. So we can imagine coming over on the y-axis, and we'll come up 1 unit. Now, let's imagine y equaling negative 2. So if we come to the left 2 units on the y-axis, well, that means z is going to have to be negative 1. So we'll come down negative 1. So now, what we want to imagine is we want to imagine that we have a couple more points on our graph. So almost parallel with this line here. We'll pass through a point up here, as well as a point down here. And the same type thing over here. So we'll come through a point down here, and a point right there. So now if I try to sketch the graph, what you want to imagine is these 3 points right here being below the x-axis. I'm going to trace my graph up to the x-axis. And then I'm going to continue above the x-axis. So there's a representation of what our plane is going to look like. So imagine this side is below the y-axis, and this side is above the y-axis. Thank you.